Now let's talk about convergent plate boundaries. As the name implies, this is where two tectonic plates come together or converge along a line. The first type we're going to talk about is when we have a continent, a continental lithosphere on one side and oceanic lithosphere on the other side. And when this happens, when continent and oceanic lithosphere comes together, what happens is that the oceanic lithosphere gets pulled underneath the continental lithosphere. This is because the oceanic lithosphere is denser. It's made up of oceanic material, which is denser. It's also cooled with age, since it left the divergent plate boundary maybe in the middle of the ocean or somewhere in the ocean. And as it's cooled, it's also become denser, and that allows it to be pulled underneath the continental lithosphere into the asthenosphere and the mantle below. This is a solid getting pulled into a solid. It's not melting away, and we have evidence that it's not just melting away as it goes down here, but just the top part of it, especially the part that has some water in it from the ocean, it's partially melting. And as this plate goes underneath the other plate, we call it subduction. S-U-B-D-U-C-T-I-O-N, subduction. There's a little bit of melting that goes on at the top of the plate, and this creates magma chambers and magma that eventually works its way up to the surface, and then we start getting these volcanic landforms right at the surface along these continental oceanic plate boundaries on the continental side. It has to be on the continental side because the oceanic plate is getting subducted underneath the continental plate. The things that we can see at the surface is the volcanic arc, and this can stretch for hundreds of miles, like the Cascade Range in Oregon. If we were to go offshore here, what we would see if we were in a submarine is we would see a trench. We would see a low area where things are getting bent down in the ocean because this oceanic lithospheric plate is getting subducted underneath the continental plate. And that's exactly what's happening offshore Oregon and Washington. We have this small plate called the Juan de Fuca plate, and it's getting subducted under the North American plate over here. As that occurs, we would have a volcanic trench that occurs here, and we're able to see that indirectly underneath the water in submarines and with cameras underneath the water. And but on the surface of the land, what we're seeing is a chain of volcanoes, and that extends from Lassen Peak in California, all the way through the Oregon peaks and up to Mount Baker in Washington state. And this is just showing how frequently they've erupted in the past. As you can see, Mount St. Helens has been the major one to erupt, with the most recent eruption being in 1980. And this is just a view of the Andes Mountains in South America. This is just another chain of volcanoes. In this image that's showing also the bottom of the seafloor, we can see where the trench would be, and we know that the Pacific plate is getting subducted under the South American plate here because of the geometry, right? This is the oceanic material. It has to be subducted underneath the continental material, but the geometry is right as well, right? First we see the trench on this side, and then on the continental side, that's where we see this continental volcanic arc. So continental just means it's on the continent. Volcanic means this is made up of volcanoes. And arc is due to the arcuate shape of this on a map or on a globe.